What up? Sorry. What up? I don't like that either. Hey, what up? I don't know. In today's lesson, here's some notes from class. Today's notes can be found on pages 3 through 5 of your packet. We finished up what we didn't complete 2 days ago on just repeating decimals to fractions. So we just talked about single digit repetition, 2-digit repetition, how one's over 9, the other one's over 99, and then of course 999 if you have 3-digit repetition, and so on. If we transition to page 4, we did one proof together, which falls back on yesterday's lesson on how to prove that a repeating decimal is in fact a fraction using the transitive property to do so. And then we move forward with the actual lesson for today, the new stuff, which is really the old stuff. It's just practice on, can you tell by sight whether or not these numbers are rational or irrational? So what I had the students do in class was to go through and to say, okay, I taught through each one of these. This is rational because it terminates. Irrational because pi is crazy. We've talked about pi many times. The square root of a perfect square is rational. The square root of a non-perfect square is crazy. Any fraction is rational, even if it's negative and improper. That's okay. If the negative is outside of a radical, that's all right. You're just looking for the negative root, in this case, negative 10. We also discussed later on how if it's underneath the radical, that's imaginary and not real. Okay, so you wouldn't actually identify it as either of those. Euler's number, discussed Euler just a little bit in brief detail. Leonard Euler, thank you. And this is a fraction, so it's rational, and so on. So we just ran through what it looks like to say rational or irrational based on inspection, just on sight. Then I had the students go through and do this on their own for a minute while I sat and just kind of twiddled my thumbs and waited for them to finish. And then I ran through with the answers. Brief discussion on each one, if necessary. Had a little fun with pi plus 3. Equated it to 2 children just arguing or bickering over something. They're like, you're stupid, you're stupid, or you're stupid infinity, you're stupid infinity plus 1. It's like, okay. But in this case, it's crazy. Pi plus 3 is still crazy. So we called it irrational. And just went through the answers here. Some people, I think, balked at this one. They weren't sure if 168 was a perfect square. It's not. It's one away from 169, which is. So therefore, it's crazy when you take the square root. But everybody kind of knew this one. 47 is not 49. So also crazy. Again, negative outside the radical, that's okay. E minus 2 kind of plays off of the pi plus 3. They're both crazy. And then repeating 0, terminating fraction. Got it. We finished up with just writing out the steps for the 5-step process. That's what I call it, is the 5-step process of proving that a repeating decimal is a fraction, because I can kind of get it done in 5 ways. Number 1, we set the variable equal to the decimal. I chose smiley face instead of n because I said, hey, you can use any variable you want, even a smiley face. That's fine. Multiply by 100 because the 2's in the hundreds place. Subtract the value of n, or in this case, smiley face. Divide by the coefficient, and then simplify if possible. Okay. So those are the notes from class. That's it. Do your work. Get her done.